Okay, the last subtopic in this video, we'd like to discuss about half-life. So half-life is the time taken for the concentrations of reactant to fall to half of its original value. So this is, if you're aware, this is the graph of the first order reaction. Why I can why? Because we should already remember, yeah, if the concentrations with time has this type of graph, this could be the first or the second order. Okay, but since this not too deep, yeah, that means this is the first order. But we can also find out that the half-life of this reaction is constant. Okay, how do we know? This is the original concentrations, which is 4. When it drops to half, which is 2, you can see that at this concentration, we can find out that the time will be here, right? So this is around 17. So T half from 4 to 2 is 17 minutes. Now let's see if the successive half-life, if the concentrations half again, fall to the half of 2. This is 1. You can find out here. This is the concentration and this is the time. Okay, around 30 something, yeah. And if you see the differences, according to this graph is 17.3, and then if it is fall to 0.5, then the T half is 16.7. So 17, 17.3, 16.7, all similar, yeah. Yeah, like 17. Okay, so we assume this is constant. If the half-life constant, the successive half-life constant, so this is confirmed it is a first order reaction. Okay, but if the successive half-life decrease with time, okay, for example this and then to this, yeah, you can see that this is large value and this is small, so the half-life decreases, so that means this is a zero order reaction. If the first order constant, how if the second order? The second order, the half-life will be increases. Okay, increase with time. So for the summary, we can find the order of reactions first through the experimental data. You should compare experiment 1 to 2 or experiment 3 and 4. Yeah, you should find which experiment that you need to use. That's how we find the order of reactants using the experimental data. Okay, and then the second, through the graph. Yeah, the shape of graph of concentration with time and the red with concentration. Yeah, if the red with concentration is like this is the zero order. Okay, like this is the zero order. Yeah, how about the first and the second? You should already know. Okay, and then for the third, we can find the order using the successive half-life. If the half-life decreases, then it is a zero order. If constant, this is the first order. If increases, this is the second order. Okay. Okay, now I have this question, practice 8. The concentrations of A and B are measured over time. Okay, you can see this. Plot two graphs, A against time, B against time, and then I, and then IV. You can pause this video and try to solve this using the grid paper. Okay, this is my graph. You can see that this is the graph of concentrations A against time, and this is concentrations B against time. Okay, use the graphs to calculate the first three half-life for its reactant and construct the rate equation for the reaction. Successive half-life. Okay, now let's do this. One fall to half. One fall to half. This. Okay. So the time is 17 here. And then fall to half again to 35. So the difference is, so the first half-life is 17. The second half-life is 35 minus 17, right? Which is 18. And then fall to half again to 0.125. So you can see the differences. 51 minus 35, it is 16. So we assume this as constant. So if around 1 or 2, we still assume this is constant. Okay, since this is constant, so first order. Because this is first order, so rate equals to K times A to the power of 1. So will be like this. How about the B? Concentrations of B against time. Okay, with the same method. 1 fall to half, so the first T half is 21 minutes. Okay, and then fall again. So the second is 58 minus 21. 37. The third half-life is 117 minus 58. Yeah, I get the value from this, yeah. 117 minus 58. The result is 59. So you can see that the successive half-life is increases, right? 21 to 37, 37 to 58 increases half-life. So this means this is the second order reaction. We can also confirm if we compare these two graphs that this is the shape of the second order reactions, right? Since this is steeper compared than the first order one. Okay, this is the second order. So because this is second order, the rate equation would be equals to K times P to the power of 2. Okay, we are done with these practice questions. So I think that's all for order of reaction and the half-life. Okay, but I have this data. Look here, methanol with HCl to form chloromethane with H2O. There are two reactants here, HCl and CH3OH. If you see the rate of reactions graph, okay, you can see that this is the shape of the second order reactions, right? The second order reactions. But the question is it the second order to HCl and zero order with methanol, or the opposite, second order with methanol and zero for HCl, or first order of HCl and second order and first order of methanol? It can be three possibilities, right? Like this, or like this, or could be like this. Okay, so if we want to confirm which possibilities is the correct one, we can we should find the the order for its reactant using the experimental data. Okay, so for the second order, it could be 0 for the first reactant and second for the other reactant, opposite, or 1 and 1. Yeah, could be like that. Okay, I think yeah, later on I will post this PowerPoint and you can learn deeper about this. Yeah. So I think there are 3 more practice questions here, 9, 10, and 11. You can try to solve by yourself. Okay. Okay. I think that's all for this video. So see you again in the fourth one. Yeah, in the fourth video, the last video, I think, because we still need to learn about the 2 last subtopics, which is rate determining step and catalyst. Okay. Bye bye, everyone. Thank you for your attention.